Why do our parts fail? It's, again, worth understanding the situations that happens to our machines. Really, there's only two causes of failure of equipment. There's only two reasons our parts fail. One is they're overloaded at the atomic structure or metallurgical structure, or they fatigue. They actually get tired from use. This top situation here is an overload situation. So this is like on the gear teeth here of this particular pinion gear. The teeth have been snapped right off. Somewhere along the line, it's got one massive overload. Now, it was working fine, something's happened and bang, this fraction of a second situation where the material strength was perfectly fine. Suddenly this load that was meant to be design load has increased hugely in this very small period of time, typically in a very small location. Now, when the engineer selects the materials for his parts, in his mind, again, he does a particular approach. This is stress, and this is just frequency. He asks the operations people, look, in this machine, what will you be doing with it? What weight of material, what sort of variety of situations will the machine be seeing? And from that, he gets an average load. He gets an average load and he says, okay, well, it'll be some sort of distribution from 0 to possibly 110% capacity, 120% capacity. So he knows the load from the operating requirements. He then says, okay, let me pick a material that is strong enough for the job. So he picks a material that is well clear of the load requirements it will see. And again, these materials typically come with a distribution depending upon where they're made. If they're made in a low-cost country, they might have low-cost materials. Made in, say in Germany, it'll be a better quality material. There's a distribution of capacity. This gap here is his factor of safety. So in the engineer's mind, he says, I have got massive capacity for any load situations. This thing should last a long, long time. So from his point of view, he's happy with that. In real life, what typically happens is when that part is in service and it's in the gearbox, and in the gearbox there is wear particles, bits of metal or bits of solids that get into the oil, then those wear particles that are typically fractions of a micron in size, 5 micron, 10 micron, when the teeth come together, the wear particle sits in the tooth. So in a very small surface area of our gear, in that very small area, when that wear particle gets trapped between the teeth, this load that was an average load, suddenly it moves up to here. And the load on that very small area, in a very small location, for a fraction of a second, becomes massive. And when these two overlap, we get the material failing. So this particular failure here is that situation there. In a very small area, huge overload, enough to start a crack, and that crack then propagates through the tooth, and the tooth falls off, and the machine's broken. The other way things fail is through fatigue. Where in this case, we have a situation of a number of overload scenarios, not full overloads, just the occasional increase, the occasional growth, for example, by distortion. When I distort that, what's happening here is this localised load isn't the average load we originally thought. The localised load actually grows for a period of time because of that distortion effect on the parts. So this higher levels here began to actually fail our machines. And so you can see here, this bit of metal has these rings. And these rings tell us that there was a number of overload situations, this scenario here, that broke a metal for a small amount of distance. Over a number of cycles, this growth rings kept growing bigger and bigger and bigger until eventually there was not enough meat left, not enough material left of the body to take the next cycle, and the whole thing just broke. So this parts, or our parts, fail in two ways. Either a massive localised overload that creates a crack in the microstructure, then propagates and breaks, or these multiple smaller high load situations that accumulate over time and we get a fatigue failure. So I can control these two factors. If I can control fatigue and control overload of our parts, then I've got a way to control the life of the machines. Because I can stop that, and if I can stop that, then they should not break. That's the whole thinking behind the plant wellness way. And wellness is literally that. Now, what is the conditions that give us a healthy life where things go well, where everything's fine and happy and the machine does what it's meant to do?